Good morning. I am Dr. P.V. Sanjeev Kumar, Associate Professor, Department of Mechanical Engineering, School of Engineering, Annamacharya University, Rajampeta. And today we are discussing an important topic in the subject theory of missions. The topic name is simple mechanism. So in our daily life we are mostly depending on various missionaries. You observe that the missions are used for doing some kind of works in our daily needs. So in this aspect of view, so a mission may have so many fundamental principles in order to make it to useful purpose. So when we call a device is a mission, you are observing so many devices associated with our life. So when you call a device is a mission, so if a device contains a mechanism, then only the device is called a mission. If a device may not contain a mechanism, we cannot call it is a mission. That is the difference between a device and a mission. So if a device may not contain a mechanism, examples I am telling, a tube light. A tube light is a device, but we cannot call tube light is a mission. And sewing machine, one example you see. Sewing machine we call a mission. We are not calling it as a device. What the difference between both that means? In the tube light you observe that it converts electrical energy into light energy. And for this conversion it is not required any mechanism. Whereas you observe sewing machine, it converts mechanical energy into useful work output. The work output is joining a cloth or stitching of two cloth pieces. So that is a small information regarding to the difference between a conventional device and a mission. So in order to study in depth the different mechanisms available for making different machineries, all mechanisms for making emissions are broadly classified into two types: simple mechanisms and complex mechanisms. When you call a mechanism is simple means a mechanism contains only 4 kinematic links or simply 4 kinematic elements, then that mechanism is called simple mechanism. Whereas a mechanism may contain more than 4 links or 4 elements, then we will treat that mechanism as a complex mechanism. Now in this session we will go to discuss the fundamental informations related to the simple mechanisms. The contents today we are discussing in this topic are the kinematic link, kinematic pair and types of kinematic pairs, kinematic chain and mechanisms. These are the important fundamental topics to understand the simple mechanism. Now we will go what is a kinematic link or kinematic element. Link and element are same. Sometimes we call it as kinematic link, sometimes we are calling kinematic element. So while discussing in future complex topics, we will understand what is the difference between link and element. But present topic, the kinematic link and kinematic element both are same. The each part of mission which moves relative to some other part is known as a kinematic link. So for making a mechanism, we are connecting several links. Like chain we are observing. A chain is a combination or attachment of several links. First link attached with the last link, then it forms a chain. It is a general observation. So a link is always goes to connect with the another link. So when you call a general conventional link is a kinematic link means a link which permits relative motion with respect to another pairing link, then the respective link is called a kinematic link. So finally the kinematic link nothing but which moves relative with respect to some other part or some other link, then the respective link is called a kinematic link. And in this aspect you observe that the link need not to be a single part. Link need not to be made by a single part. A link may consist of several parts, but there is no relative motion of the several parts, treating it is a kinematic link. A link may contains more than one part also, but the containing parts there is no relative motion. So this is important information to remember, the difference between part and a link. A part is a link, kinematic link need not to be a single part. It may be a combination of several parts also, but this combining parts there is no relative motion. But link we should have a relative motion with respect to another link. So then only the link is called a kinematic link. So there are two important characteristics or properties we have to discuss under the kinematic link. A kinematic link should possess the two important characteristics. Number one is it should have a relative motion with respect to another link. This is the most important characteristic. And another one is link must be a resistant body. What is the meaning of resistant body means? The resistant body and rigid body, there are two types of bodies we will observe from the mechanics point of view. The rigid bodies, they should not undergo any deformation, whereas the resistant bodies may undergo some deformation. So link must be a resistant body. So it cannot expected as a rigid body. So rigid bodies cannot transmit any deformation, but resistant bodies can have small deformation. So these two are the important properties for kinematic element or kinematic link. Just remembering once again, the important characteristics of a kinematic link are it must be a resistant body and it should have relative motion with respect to another. Now we observe, just now I told you, link need not to be a single part, it may be a combination of several parts. One mechanism I am showing you in this slide. The name of this mechanism is reciprocating steam engine mechanism. Reciprocating steam engine mechanism. In particular, it comes under a single slider crank mechanism. What is single slider crank mechanism? In the next topics we will discuss. So it contains a 4 links. You are observing in the figure, several parts are there, but several part is different from a link. Part is different from a link. So from the subject point of view, this mechanism contains 4 links only. Therefore, it comes under a simple mechanism. Simple mechanism. So the 4 links I am going to tell here. The first link is the piston rod and the cross line. This is the piston rod and this cross line. These 3 parts unitedly called a link 1. Just now I told, a link need not to be a single part, it may be a combination of several parts. These 3 parts are having no relative motion with respect to each other, but as a link it is having a relative motion. So in this case, link 1 is piston rod and cross line. It is one link. The second link, what you are observing from the here is small end bearing, connecting rod and big end bearing. These are the 3 units or 3 parts. Small end bearing, connecting rod and big end. These 3 put together as a one link, that is second link. And these 3 parts have no relative motion. But as a whole, link 2, it is having a relative motion with the link 1. The link 1 again I am emphasizing. Link 1 is piston rod and cross head. 3 units are put together one link. The second link is small end of bearing, connecting rod and big end of bearing. So this is the second link. So they are having relative motion with respect to each other. Therefore, these 2 links are called kinematic links. And third link, what you are observing here is the crankshaft, crank and crankshaft, and backside flywheel is there. So these 3 are the 3 parts. They are having the same kind of motion, and we treat those 3 parts are another link. So the third link here contains 3 parts. The 3 parts are crank, crankshaft and flywheel. So they have the same motion. All are rotating motion and treated as a one link. 3 parts put together as a one link. That is the third link. And what the fourth link is? Fourth link is a cylinder and engine frame. Cylinder and engine frame. And it is fixed, it don't have any motion. So finally I am telling, to make a mechanism, combination of all these four links as a simple mechanism, at least one link should be fixed. This will discuss at the end, the definition of a mechanism. So here you notice, this mechanism contains four links. The link one contains three parts. The names are piston rod and cross rod. And the second link is a small end bearing, big end bearing and connecting rod. These three are treated as a second link. The third link is flywheel, crank and crankshaft. This is the third link. The fourth link is the cylinder and engine frame. Okay, now, so you observe in this mechanism, the fourth link is fixed. Why it is fixed, we will discuss in the next topics. So it contains four links, therefore it comes under an example of simple mechanism. So next we will discuss what is kinematic pair. If two links are elements of a machine, when they are in contact with each other, they are said to form a pair. So you observe that any two links you take and connected each other, definitely they are forming a pair. So it is generally simple pair. But when you call this pair is a kinematic pair, means the relative motion between these two links of a pair is completely constrained or successfully constrained. What is the meaning of constrained motion? Means the motion have a particular direction, then the respective motion is called a constrained motion. This will discuss in the next topics in detail. So a link is connected with respect to another link to form a pair. Okay? And this pair having a relative motion, and this relative motion is completely constrained motion or successfully constrained motion, then the respective pair is called a kinematic pair. If the pair is not having a constrained or successfully constrained motion, then we should not call it as a kinematic pair. So the important conclusion I am telling, when we call a pair is a kinematic pair, means if the pair permits a relative motion which is constrained motion or successfully constrained motion, then only the pair is called a kinematic pair. There are several classifications of kinematic pairs. So several criteria are considered for classifying the kinematic pairs. So we will discuss this kinematic pairs in detail in the next topics.